Space Weather: Unleashing the Power of Solar Storms. Title: Space Weather: Unleashing the Power of Solar Storms. Introduction. Space, with its vastness and mystery, has always captivated humanity's imagination. While astronomers and scientists continue to uncover the secrets of distant galaxies and celestial bodies, one phenomenon lies closer to home, shaping our very existence: space weather. Specifically, the awe-inspiring power of solar storms has become a topic of great interest in recent times. In this article, we will explore the fascinating world of space weather, delve into the science behind solar storms, and discuss their impact on Earth. Understanding space weather. Space weather refers to the conditions and events occurring in the near-Earth space environment, influenced primarily by the Sun's activities. Just as Earth experiences weather patterns such as rain, wind, and storms, space too has its own set of weather phenomena. Space weather encompasses a range of solar phenomena, including solar flares, coronal mass ejections, CMEs, and solar wind. The Sun, a powerhouse of activity. At the heart of space weather lies the Sun, a majestic star whose ceaseless activity governs our solar system. The Sun's surface, known as the photosphere, is a fiery maelstrom of gas, constantly bubbling with magnetic fields. Over time, these magnetic fields get tangled and compressed, leading to the formation of sunspots. Sunspots are cooler, dark patches on the Sun's surface with intense magnetic activity. Solar flares, explosions of energy. When the Sun's magnetic fields become highly twisted and complex, enormous amounts of energy can be released in the form of a solar flare. A solar flare is a sudden, explosive eruption of electromagnetic radiation, spanning a wide range of wavelengths. These powerful bursts of energy can release as much energy as billions of nuclear bombs. Solar flares emit a substantial amount of high-energy radiation, including X-rays and ultraviolet (UV) light. While the vast majority of this energy is fortunately absorbed by the Earth's atmosphere, space-based satellites and astronauts in space can be vulnerable to these radiation bursts. Additionally, solar flares can cause temporary disruptions in radio communication systems and electrical power grids. These colossal eruptions project billions of tons of superheated gas into space at millions of kilometers per hour. When a CME directed towards Earth arrives, it interacts with our planet's magnetic field, causing geomagnetic storms. These storms create mesmerizing displays of light known as auroras, predominantly seen near the Earth's polar regions. Space weather forecasting. Given the potential impact of solar storms on Earth, researchers and scientists have been working diligently to develop space weather forecasting capabilities. Similar to terrestrial weather forecast, space weather forecasts aim to provide timely and accurate predictions of solar activity. Monitoring the Sun for signs of impending solar storms involves a combination of ground-based and space-based observatories. Satellites such as the Solar Dynamics Observatory (SDO) continuously observe the Sun, measuring factors such as magnetic fields, solar wind velocity, and energetic particle fluxes. These observations, combined with advanced computer models, enable scientists to forecast solar events and anticipate their impact on Earth. Mitigating the risks. While it may seem alarming to consider the potential risks associated with solar storms, efforts are underway to mitigate their impact. International collaborations have been established to enhance space weather monitoring and forecasting capabilities, allowing governments and organizations to take preventive measures. Satellites and spacecraft are designed with robust shielding to withstand the harmful effects of solar flares and knees. Power grids are also being hardened by implementing measures to minimize the impact of geomagnetic disturbances induced by solar storms. Furthermore, space weather monitoring systems continually provide crucial data to airlines, enabling them to reroute flights away from areas of increased radiation risk during solar storm events. Precautionary measures help maintain the safety of passengers and crew while limiting potential disruptions caused by space weather. The exploration of space weather and the power of solar storms is a fascinating endeavor. Scientists and astronomers continue to unravel the mysteries of the universe, but there is something captivating about considering the effects of space weather on Earth. Space weather refers to the conditions and events in near-Earth space that are influenced by the activities of the Sun. Similar to Earth's weather patterns, space has its own weather phenomena. Solar flares, coronal mass ejections, CMEs, and solar wind are all part of the vast range of solar phenomena that contribute to space weather. At the heart of space weather lies the Sun, a powerful star that governs our solar system. The Sun's surface, known as the photosphere, is a constantly active area with bubbling gas and magnetic field. These magnetic fields can become tangled and compressed, leading to the formation of sunspots. These sunspots are cooler and darker than the surrounding area due to intense magnetic activity. When the Sun's magnetic fields become highly twisted and complex, immense amounts of energy can be released in the form of a solar flare. A solar flare is a sudden eruption of electromagnetic radiation. These bursts can release energy equivalent to billions of nuclear bombs. While most of the energy is absorbed by the Earth's atmosphere, satellites and astronauts in space can be vulnerable to radiation. Solar flares can also disrupt radio communication systems and electrical power grids temporarily. Sometimes, a solar flare is accompanied by a massive release of plasma and charged particles called a coronal mass ejection, CME. These eruptions can project billions of tons of superheated gas into space at incredible speeds. When a CME heads towards Earth, it interacts with the planet's magnetic field, causing geomagnetic storms. These storms produce mesmerizing auroras near the Earth's polar regions. However, CME-induced geomagnetic storms can also disrupt power grids, affect satellite communications, and pose radiation risks to astronauts and passengers on high-altitude flights. Understanding the potential impact of solar storms on Earth, researchers and scientists have been diligently working to develop space weather forecasting capabilities. Ground-based and space-based observatories, such as the Solar Dynamics Observatory, STU, continuously monitor the Sun for signs of impending solar storms. These observations, combined with advanced computer models, enable scientists to forecast solar events and anticipate their impact on Earth. To mitigate the risks associated with solar storms, international collaborations have been established to enhance space weather monitoring and forecasting capabilities. Satellites and spacecraft are designed with sturdy shielding to withstand the harmful effects of solar flares and CMEs. Power grids are also being fortified to minimize the impact of solar storm-induced geomagnetic disturbances. Furthermore, space weather monitoring systems provide crucial data to airlines, allowing them to reroute flights away from areas of increased radiation risk during solar storm events. These precautionary measures help ensure the safety of passengers and crew while minimizing disruptions caused by space weather. Solar storms are indeed a captivating aspect of space weather. As we delve deeper into the mysteries of the universe, we cannot help but consider the effects of space weather on our planet. Space weather refers to the conditions and events occurring in near-Earth space, influenced by the activities of the Sun. Just as Earth experiences weather patterns, the space environment also exhibits its own set of weather phenomena. Solar flares, coronal mass ejections, CMEs, and solar wind are all part of the wide range of solar phenomena that contribute to space weather. At the center of space weather lies the Sun, a powerful star that governs our solar system. The Sun's surface, known as the photosphere, is a constantly active area with bubbling gases and magnetic fields. Over time, these magnetic fields can become twisted and compressed, resulting in sunspots. These sunspots are cooler and darker than their surroundings due to intense magnetic activity. When the Sun's magnetic fields become highly twisted and complex, it leads to the release of enormous amounts of energy in the form of a solar flare. A solar flare is a sudden and explosive eruption.